Hey everyone, today we are solving LeetCode problem number 867, Transpose Matrix. So in this problem we are given a 2D integer array matrix and we have to return transpose of this matrix. So what is the transpose? Transpose the matrix is the matrix flipped over its main diagonal, switching the matrix row and column. Okay, so let's say in this example we are having a matrix of 3 cross 3. So its first row will become the column, first column, second row, second column, third row, third column. Or you can, if you want to analyze it further, these values are flipped diagonally. 2 minus 10, 4, 8, 18, 5 minus 1, 18, 5 minus 1, 11 minus 7, 11 minus 7, like this. So these are the main diagonal. So how many diagonals do we have? Can we have in this m cross n metric? So if m is the number of rows, n is the number of column, so we are going to have m plus n minus 1 diagonals. 3 for each row and then 2 for each remaining column. 0, 1, 2, 3, 4. But in this example, we are also given some constraint like m is the matrix length, which is number of rows, n is the number of column, and m and n value can be from 1 to 1000. So it is not necessary that we are going to get the same m or n values. M is not equal to n here in all the case. So we cannot directly flip the values of its diagonal, because we have two possibilities. Either we do whatever it is mentioned in the problem, switching first row with the first column, second row with the second column, like this. Or maybe if we have to do it in place where m is equal to n, in that case we can switch values over its diagonal. So we cannot do that because m and n not necessarily to be equal. So we have to take a new metric where the number of rows will be n and the number of column will be m, and we have to iterate over given array and fill the resultant array. So for every row and column, row will become column, column will become row. So in short, we don't have to do anything special, just iterate over this array and fill our resultant metric. So in this case, time complexity would be O of m into n. We are processing each column against each row, so m into n. And the space complexity will also be O of m into n, because we are taking an extra metric, extra 2D array to store our metric transpose. Okay. So, but in the interviews, you can be asked with the follow-up question to this problem. Like they will say that number of rows and the column will be equal. If both are equal, in that case, we are supposed to do that in place. So how do we do that? Just flipping all the values against each diagonal. So here you you can see that for each row 1, 2, 3, with there is one diagonal, and for each subsequent column we have a diagonal. So m plus n minus 1. So total number of diagonals are m plus n minus 1, and each diagonal is having a sum of 0 to m plus n minus 1, or maybe minus 1. So in this case it is 0, 1, 2, 0, 1, 2. So this diagonal is having sum of 0, 1, 2, 3, and 4. So this 11 and minus 7 is going to have a sum of 3. So diagonal sum is going from 0, 1, 2, 3, 4, like this. For 0, we only have one value, 0, 0. For 1, we have 0, 1, 1, 0. For 2, we have 0, 2, 1, 1, and 2, 0. And for third column, we have 1 comma 2, 2 comma 1. For fourth column, we have 2 into 2. So here you can assume, you can see that we have to flip values among each column. But how do we decide? For every ij element in any column, if I is less than j, let's say we have 1 comma 2, it means we will definitely have 2 comma 1 in this case, because it's a diagonal in this metric. So if I is less than j, in that case we are going to swap value of ij with j of I. So in this case, in the third column, we are going to swap these two values. In the second column, these two values will be swapped. In the first column, these two values will be swapped like this. So here, this and this will be swapped, this and this will be swapped, this and this will be swapped, and this will be our in place solution. But as we don't have m equal to n in this case, so we have to take an extra space and iterate over our given array to form the transpose. Okay, let's quickly code this out. Here we are given a metric, so let's capture its number of rows and column. Matrix dot length int and number of column. Matrix dot matrix 0 dot length. Okay, now iterate over it. 0 less than m for j equal to 0, j less than n, j plus plus. What we have to take is we have to return a new metric. Let's form that metric. Integer 2D array result equal to new integer. This would be n cross m, not m cross n. So result of j and I will be equal to matrix I comma j, and we are done. Sample test cases are passed and the problem is submitted successfully. Okay, thank you guys.